That kind of leads to this other question.
There's no way to restrain it. They came over and was like, that was
Uh,
okay.
If you look at the textbook on page 62,
Right?
No.
And there's still a question in process
Why
here.
didn't that make, why didn't I think about that?
Okay. Let's bring it back, hold on. I know physics makes you really excited. Right, you were saying, page 62?
62, there's a little box there, and it says velocity squared equals velocity, initial velocity squared minus 2g, and then times change in y. Now, if you
Oh,
look-
yeah, okay.
Now, if you look at page 56, there's that same equation, but they're using a instead of g.
Yep. All right.
Where they're adding adding to the initial velocity as opposed to subtracting from it. Now, is that because the whole gravity?
The gravitational, acceleration of gravity is downwards. So if you automatically make up positive, then on those problems, acceleration would be negative g. I'm not sure, I could have picked a worse marker. I'll pick it up later and reuse it. It's negative g, and so what they did is they put in negative g in for a. And that's why it's negative sign on page 62.
Right, and the heading on that box at that, where it does say negative g is free falling objects. These pertain to free falling objects, and that's because when you're free falling object, the acceleration is negative.
Or slightly differently, when the only force acting on it is the force due to gravity.
Okay, then it's always negative.
Well, it's, the magnitude of the acceleration is always little g, the direction is always down, whether that's negative or not depends on
Okay.
your convention.
Standard convention down is negative.
Sure.
That's why they have it listed as negative.
Yeah.
It just struck me as, I'm like, okay, wait a minute, they're saying it's positive over here, and then they're saying it's negative over here. It's just,
That's where it comes from.
okay. That's what I got for last. That's why I vacillated and said, no, it's the other one. Oh, well.
Yeah, in a situation like that where you're actually thinking through and thinking which way is it, you could always just change the number slightly, not for the final answer, but if the answer had been 0.1 seconds, then what would have happened? You would have gotten, no, that wouldn't necessarily elucidated. If you made the acceleration due to gravity huge, then with initial velocity and acceleration both positive, if acceleration due to gravity is huge, you would have gotten a huge cliff there. But if you think about it, if I have a higher acceleration due to gravity, that thing should have plummeted much faster. So you would have gotten, no, that's still, all right, I might have to delete this part too.
Well, I looked at my sketch and it looked like it was 65, or 65 meters.
Can I like maybe get my paper back? Like
For?
maybe,
To throw in a minus sign there?
like maybe.
Yeah, I'm gonna hand it back to you with a grade on it, sure.
Okay.
You know, in the end, there are a slew of quiz grades. This is not gonna make or break any of you.
In question 47, we get the acceleration at negative 9.8 in A,
Okay?
and in B, we get the positive 9.8. Like inside the.
It's a different problem. I mean, even though you're keeping some information the same from the previous bit, it's a new problem. You can set up a new convention. You don't have to use up as positive throughout the entire problem.
So why did he change the sign?
Some of my explanation for why the discrepancies in the solutions, it almost comes across like they had different people working on it. And so whoever did part A was different than the person who did part B. Or maybe they did that just to sort of emphasize the idea that you don't have to keep the same convention.
Right.
Because in part B, it's going downward, so it's only going in one direction, so I mean, there's no harm in making that the positive direction. Or if you made it the negative direction, then you had a bunch of negatives that would all cancel out. I'm not feeling there's many happy campers going on right now, but,
Just annoyed with myself. I'm kicking myself like right.
Olivia?
Oh,
Okay. I was thinking that this problem right here would just pick people's spirits up.
100%.
Absolutely, okay. Any questions?
Another cliff we're jumping off of?
We're jumping into the air, 50 meters per second. I will say that if you could jump at 50 meters per second, then I think the Olympic Committee is looking for you.
How fast would that be?
105 miles an hour.
Yeah, that's pretty impressive.
100.
Yeah, double it plus a little bit. All right, so let's do this. If you've got some burning question, you can always email me or, Monday, start out when I say, are there any questions? Ask at that point. I apologize if there's a question out that was hanging out there that I missed. I didn't really want to do this. So.
What?
All right, so projectile motion. Chapter 3 is big into the two-dimensional problems. So let's start out with the classic projectile motion where you're given initial speed and direction, the height, and the question is where does it land? As shown in class the other day when we dropped the ball and shot another one at the same time and they hit the ground at the same time. So the time it takes for the ball to move vertically is the same time it takes it to move horizontally, which should not be a shock. When it hits the ground, it kind of stops moving both. But we need to treat this as two problems, which have a common link. The common link is time. Now, we did the sum on Monday when we shot an object out horizontally, but the same principle holds true, just the math is slightly more complicated if we shoot at an angle. So the first step is write down what we know. So what do we know?
We know the height of the cliff, which would be
So you can't read my handwriting, or,
no, it's like 20, but I don't know where it would go. I guess like displacement, right?
okay, I had two displacements, I got an I and a J.
Right.
What's your displacement?
Yeah, it's vertical, that 20 meters is vertical, so it's gonna go in the J. And 20 meters, is that what you wanna go with? All right, so we have now established our convention that down is positive. Because it does end up lower than it started. All right, so that's the nice bit of information right there. There are a couple other numbers there. The question is, what do we do with that? I know my velocity, 50 meters per second, at an angle of 30 degrees. So that's 30.
So we have our initial velocity of 50 meters. That's just like a trig.
Yeah, we do have our initial velocity, but we can't really fit that into it because that 50 is at an angle,
Oh,
and I'm breaking it into I and J.
right. Gotcha.
And so we need to figure out how much is horizontal and how much is vertical. Flash back to first day, second day.
Right triangle trig.
This will be 50 times the sine of 30 degrees, which is 25. And this will be 50 times the cosine of 30 degrees, which is 37 point something.
30, I have 43.
43.
0.3.
This would be meters per second. So my horizontal here, 43.3 meters per second, and my vertical, 25 meters per second.
Although, would it not be negative since we decided to put positive 20 meters?
It would be, thank you. And the J component is negative, because Ian and Brooke wanted down to be positive.
We didn't know what we were doing when we got into it.
Forget-
We have to like accommodate, yeah.
All right, so that's the information we're given directly in the problem. There's one other piece of information that or two more things that we can fill in just from the nature of the problem, not from the facts given in the problem, other than the fact that we have an object shot through the air.
Is this on Earth?
Yes, it is. Assume it's on Earth,
Negative
therefore,
9.8.
where?
Positive 9.8.
Yeah, it'd be positive.
Oh, yeah, sorry guys.
Where?
Where?
Oh.
Acceleration for.
J side.
For both.
J side.
J side. That 9.8 is
Oh, yeah.
vertical.
It's horizontal, right?
So it would be 0 for the,
Yes.
Why is it 0? Okay, never mind.
The only force acting on it is the weight of the object, and that is down. Now, some people have had issues in the past with, yeah, but if I'm throwing something off the cliff, what about my hand? That's not part of the problem, that's a different problem. We're only concerned with once it's been launched. Let me correct the mistake I have up here. All right.
What? Why is that 25 negative again?
Because they said so.
Okay.
Big made 20 meters positive, and it ends up, at 20 meters is down, it ends up below where it started,
Okay.
and if that's positive, that's negative,
Just don't put it on there.
and that's positive. Now, let's say you're sitting there and you're thinking, I can't believe them, those fools. And you wanna make up positive, that's fine, just change the sign of these three things. It will not affect your final answer. So I have three things on the vertical, so I can find the other two if I need to. On the horizontal, I know two things, so I can't solve for anything yet. I guess potentially I could solve for final velocity here, horizontal, but that doesn't really help us much. What is my final velocity horizontally?
0?
No.
Horizontally.
Yes, because there's no acceleration horizontally, that means the velocity does not change horizontally. Now here's a situation where we do know three things, however, we cannot find the other two. The acceleration being 0 sort of messes up that scheme. We need to find time. How long is this thing in the air?
Oh. I see.
And so you pick the cake formula, which does not have final velocity in it.
Is that the like VI?
Yeah. Wait, times time plus half.
One half of acceleration times time, yeah.
So delta x, y, whatever we're using.
Yeah.
So we end up with 20 equals negative 25t plus 4.9t squared. What is it?
How did we get, the 43.3 for the final velocity?
Oh, and there are a couple ways of doing it. Because acceleration is 0, if you think about the cake formulas, we have the vf squared equals vi squared plus 2a dot delta s. Because acceleration is zero,
Oh,
the term drops out
yeah.
completely.
Would be zero, so it would be this, okay.
Yeah. Or conceptually, acceleration of zero means that the velocity is not going to change. And so therefore the velocity should stay the same. Other questions up to here? All right, so we now have a math problem. Question is, how do you solve it?
Quadratic formula,
Okay, what do you need to do first?
move 20 to the other side.
All right, so this becomes 4.0 equals 4.9t squared minus 25t plus minus 20. So, the time is 25 plus or minus the square root of 625 minus 4 times 4.9 times negative 20 divided by 9.1. I know the discriminant's gonna be positive, so we're not gonna have to deal with that issue. So, now, as you're working this out, there will be two times here. I expect there to be one positive and one negative, and I expect that the magnitude of the positive time is bigger than the magnitude of the negative time. And the reason for that is, again, the math problem is looking at a parabola here. Starting at this point, moving in that direction, because it's thrown upwards, up and to the right. This thing is going to cross my axis here and here. So I expect a negative time and a positive time, and the absolute value of the positive time is bigger than the absolute value of the negative time. So this should give, at least we'll have some hint whether our two answers make sense. Then,
Do we turn in the master set online or in person?
you would hand it in just like you would a lab or anything else. Yeah, master sets to be handed in. In the past, I've had some students that got the habit of emailing that to me, and the trouble with that is when I'm grading it, I got a stack of papers here, and then I have to remember, oh, wait a second, I have to go online to find something that's been emailed to me, so I'd much prefer paper. So what do we got? Looks like some people have answers.
I got 5.805 for the positive time,
And the negative one?
negative 81.35.
Whoa,
I don't know if I did that right. I'm gonna go
yeah,
back.
something's off there.
I got negative 0.7.
Okay.
You had negative 0.7.
Yeah.
Did you get the same positive?
I got a different one.
Yeah, I got the same positive.
I don't know.
Alright, so, Brooke, you had something different?
Yeah, I just deleted it, I'm gonna try it again.
Okay.
Okay, that's different too, I don't know what I'm doing wrong. I think I do know what I'm doing wrong.
The most common mistakes, the people who use the TI 80 whatever, so it's like you're not using one of those, but TI 80 whatevers, it's usually parentheses in the wrong spot. That you end up dividing just this by 9.8 instead of the 25 also, but it's hard to tell. All right, so we got our 2 times. Absolute value of the positive is indeed bigger than the absolute value of the negative. It makes some sense. Anyone have a different answer?
I got it now.
All right,
I got the 0.7 now that I fixed the
okay.
negative.
We now have time, 5.805 seconds, 5.805 seconds. We can now find horizontal displacement. And that's basically the same equation. The biggest mistake I see students make on this problem is they stick in acceleration of 9.8 meters per second squared no matter what. So you got the sign issue, but putting in 50 for the initial velocity and 9.8 for the acceleration, I look at that and I'm thinking, this person does not understand, and I tend not to give any partial credit for that. What goes into the equation should be of similar ilk. All the stuff we put into this equation here is all vertical. The stuff we're gonna put into the equation now is all horizontal. If you put in 50 for the initial velocity and 9.8 for the acceleration, you're now dealing in two different directions. You have 50 meters per second that way, and you have 9.8 that way. It turns out the world does not work that way. So as we plug in, I have delta x is equal to 43.3 times 5.805 plus 0, because there's no acceleration. This was right out 4 1. So it's a classic distance equals rate times time. 43.3 times 5.805, 200 and something.
251.35.
251.35?
65, yep.
65.
Oh, 3565. But just 35 and 36.
Units?
Yeah.